right, it's 5 past the hour. So I'm going to go ahead and introduce Steve and myself. Hang on one second and I will stop sharing so you can see me. There we go. Okay, I hope that you are, let me see. Oh, there we go. I can even do this. Yay. All right, so my name is Lee Liming. I'm the Director of Professional Services for Globus at the University of Chicago. And I'll be giving part of this tutorial. My colleague, Steve Tarosi, who I will turn it over to in just a second, is joining me, and he will be doing a big chunk of the interactive part of the tutorial. And hopefully between the two of us, you'll have two different voices. I'm now highlighting Steve. Steve, do you want to say hi?
Yes. Hello, everyone. Lee, already said my name is Steve Tarosi. Been working for Globus Chicago for about 3 years now as a professional services manager. And I'm going to be doing the Globus Compute portion of this tutorial and hopefully get some folks in there and do some hands-on stuff. Thanks, Lee.
All right, so I'm going to go ahead and reshare my slides again. Let me make sure I get the right window this time. All right, you should be seeing my title slide. Is that right? Uh-oh, now you should be seeing the prepare for exercises. So this is going to be an interactive tutorial. It is 180 minutes long. We'll be ending in Mountain Time. It is currently 8:07. We'll be ending around 11:30. So do the time conversion where we're 1 hour ahead of Pacific time, 2 hours behind Eastern time. During this tutorial, you will have available to you exercises online that you can do interactively. We've deployed everything for you, got it all ready, and you'll be able to log into systems and run through the exercises that we will show you on the screen. If you want to get ready, use this QR code, or there's actually a longish sort of short URL, US-RSE'24 Globus after the bit.ly domain name. And that will take you to a resource page that has links to everything that we'll be using in the tutorial. So I would encourage you to open up your browser, go to this link, open up the resources page, and you'll be all set for when we get to the interactive portion of the tutorial. Just a quick summary of what we're going to be doing today. We've divided the tutorial up into 45-minute segments. There are 4 of them. We're starting the first one right now. This is the introduction section. So about 45 minutes past the hour, we will move from well, let me first say the introduction will make sure that we're level set on what Globus is and what we're going to be covering in the tutorial today, where it all fits in into the landscape of research computing and so on. About 45 minutes past the hour, we're going to switch to the section on Globus Compute, and that will be talking about remote function execution, the ability to run Python functions on systems other than the one where your application is running. So wherever you have compute available, you can run Python functions using Globus Compute. We'll take a break at the hour and a half marker, and that'll be a 30-minute break. So we will have a good long 30 minutes for everybody to relax a little bit. I'm going to make myself some coffee and maybe have a little snack. And then we'll come back again at 2 hours past and start to learn about Globus Flows. Globus Flows is the automation portion of Globus. So it's the part where you get to define a whole series of actions that you need to have executed in order. And then from then on, you can make those actions happen over and over and over again just by executing a function call, API, actually an API call. For after that, we will have the last segment, 45 minutes will be spent on putting together compute and flows. And so we will show you how to build a flow and an automated series of steps that include Globus Compute actions in the flow. So part of the flow will be running compute jobs on other systems. And that will be what the whole tutorial. So one thing I wanted to mention before I get started, we will be at the conference in Albuquerque next week, Tuesday through Thursday. And so I would strongly encourage you to come and visit us in person. Steve and I will both be there. We'll have our colleague Andy Boughton with us, and we will have a table in the sponsor area. And we will also be doing the afternoon workshop on Tuesday afternoon, which will be essentially a repeat of this tutorial. And so if you feel like you would like to hear something over again or ask a question in person, you are more than welcome to crash the workshop on Tuesday afternoon. So very quickly, I want to remind everybody that Globus is a nonprofit service developed by and operated by the University of Chicago. We are research software engineers ourselves. Our whole team is research software engineers, and we provide the Globus services to the research community. Our mission at Globus, in the Globus team at University of Chicago, is to increase the efficiency and effectiveness of researchers engaged in data-driven science and scholarship through sustainable software. So I'll say a little bit more about that in the next few minutes, but one thing I want to point out is that we base our success on your success. So the degree to which we're able to help you achieve wonderful outcomes in research and research software is the degree to which we feel that we're being successful. We don't really have any other goals. We don't have any, research that we are trying to accomplish ourselves or anything like that. We are all about enabling other teams to do amazing research. Globus is very widely deployed at research institutions around the world. There's a very heavy concentration excuse me, of Globus availability in the United States, particularly in the research universities um, in the United States. We have more than 500,000 people who have logged into Globus over the last 12 months. So this is just 1 year. We've been in operation for 14 years now, the online services. Our group existed as a group, and we were developing Globus software for about 15 years before that. But only in the last 14 years have we been providing online services like the ones I'm going to be telling you about today. But the 500,000 number is just in the last year. There have been, of course, a lot more people who've used it over the previous 13 years. Globus is integrated already with systems at most research universities in the United States and many of the leading research universities around the world. You can access all sorts of data from Globus-enabled services around the world. And much of the research computing resources, both storage and now compute with Globus Compute, are already connected to the Globus system. So you don't have to do anything in order to use Globus with them. The administrators of those systems have already done that work for you. We're talking about thousands of research institutions. On this screen, you can see 2,600 plus connected institutions. Each of those has at least one system on it that's available via Globus. And there are on the order of 60,000 active Globus collections, that is, things that are available using Globus. And we do cover about 80 of the countries around the world. We also, our data transfer service, which is not what we're going to be talking about today, is very active. It's our oldest service, and we are regularly transferring almost 2 petabytes of data every single day for the research community around the world. So what do we do at Globus? One way that I like to use to describe what we do at Globus is we're trying to create a new way to do research information technology. That is to say, to do research computing and research data management. Um, we are we have all, many of us on the Globus team have used research IT in previous lives. I have been around for quite a while, and I was using research computing in the 1980s and the 1990s. And I have to say that when I joined the Globus team around 2000, I was already pretty frustrated at the state of research computing. And what's really frustrating is that it still hasn't changed a whole lot in the last 20 years. There are an awful lot of researchers who uncomfortably discover that in order to use some of the most powerful supercomputers in the world, they first have to learn how to do things like get a remote terminal session and learn the Linux command line. This is kind of frustrating because this is not how people interact with computing in other fields. This is not how you use social media. This is not how you use websites for all sorts of businesses that you interact with. It seems silly to us that you should still be using remote terminal sessions and command lines and really clunky software in order to use research computing. And so we're trying to reimagine that by providing software as a service that you can use in your web browser, just like you use any other application that you get from industry providers. By making things very reliable and easy to use, and by providing beautiful user interfaces that are accessible and that adapt to your needs, depending on what those may be. Um, so some of the things that we have already, some of the problems in research computing that we've already tackled are here on the screen. The oldest, again, is managed data transfer and data synchronization. So if you need to get data from one system to another, Globus makes that very, very easy. What is most important for researchers in our data transfer is that it works across institutional boundaries and the accounts that you have. So if you have different accounts on two different systems, that's fine with Globus. You log into each system with the account that you have, and then you can transfer data from one to the other without worrying about the fact that one end doesn't recognize the account that you used at the other end. And you don't have to get accounts everywhere in order to move data. We make data sharing with your colleagues easy. So if you have a colleague at a different university or at a research institute where they have a different account system than you have, you can still share data with them using Globus, using our sharing feature. Also, Globus data access and data management works the same way, regardless of whether you're using your personal system, a supercomputer, a commercial cloud, or some kind of mass storage in a research computing system. So we provide the same interface for regardless of whether it's big storage, little storage, cloud storage, on-prem storage, or your personal computer. We also provide publication and discovery services. In the end of this exercise, we'll dabble very briefly in our Globus search service, and I'll show you how easy it is to add entries to a search index and make it searchable. We'll worry about that when we get there, don't worry. And today, in the green box, we're going to be talking about two of the more recent services in Globus. Our remote execution service, Globus Compute, and our automation system called Globus Flows. So these are the two that this tutorial will be covering today. All of these things are being provided as platform as a service, which means that there are APIs, RESTful APIs that you can call. Built on top of that, you can use our Python command line interface, which provides access to everything that's API accessible. And built on top of that is our software as a service, which is a web application that you can use in your browser. And we'll be using that quite a lot today to check on our automations and see how things are going. So you'll be able to do that in your web browser without any kind of command line or anything like that. Since I've kind of said bad things about command lines, I do want to make say one thing that's a little cautionary. We will be using the command line briefly in this tutorial. And there's a good reason for that. You actually have to install a piece of software on our EC2 instances. We basically gave you a login server that you can log into, and you're going to see how you can make that make it possible for you to execute remote functions on that. And in order to enable that system to accept remote functions, you need to install a little bit of software. But I promise you, it will take you less than 2 minutes to do that. It's very easy. I did it last night in like 2 minutes, and I was done. And then I could move on and not use the command line anymore. And that's really what we're all about, is trying to make things very easy to use using modern interfaces. So another way of looking at it is that, and this is really what is important about Globus as opposed to other systems that do the same thing. Globus is all about enabling you to use the institutional resources that you have access to as a researcher. So research, storage, compute, instruments. And these are systems that probably have already been set up for you, either by your lab administrator or by your campus's research computing administrator, making it easy for you to use those things without having to learn a lot of arcane interfaces. Making it easy for you to use those systems with accounts that you already have, probably your university or your employer's account system, whatever they've set up for you. So I work for the University of Chicago, and when I use Globus, I usually log in with my University of Chicago single sign-on account. I don't have to have a special account to use Globus. But you can also, if you need to, use systems like Orchid or Google to sign into Globus as well. And then again, everything that we provide is available as a platform, which means that as a software developer or a research software engineer, you can access all of this stuff using our APIs. And we provide the full suite of RESTful APIs, a JavaScript SDK for web applications that you develop, which is hosted in Amazon for you 24/7. Our Python command line interface that you install with the standard PyPy pip install or whatever Python installer you use. Our Python SDK, same distribution. And our web application, which is hosted in Amazon and is available all the time in your web browser. So most of Globus is software as a service, which means that you can access it without installing any software of your own. You either use your web browser, or you would use the Python command line tool, or if you want to, you can develop using the Python classes that we provide for you in our software development kit. But that begs the question, how do you make your systems, how do you make your compute and your data available to Globus so that you can use them with these nice interfaces? The answer to that is that we provide actually three pieces of software, two for data and one for compute. The two for data are called Globus Connect. There's a server version and a personal version. That is used to make the data on a system available via Globus. Does not mean that you're sharing the data with the world. It just means that you are making it possible for you as the owner of the data to share it with other people or to access it using the Globus interfaces. So once you or once an administrator has installed Globus Connect on a system, you can then, if you have an account on that system, or if somebody has shared the data with you, you can access it in Globus. It's all secure. It is, like I said, it's not publicly available. It's only available to people who are authorized after the software has been installed. You have to then grant access to people who you want to have access to the data. Globus Connect Server is intended for multi-user systems. So if there's a shared storage system that has hundreds of accounts or even dozens of accounts on it, you can make it possible for anybody who has an account on the system to access it using Globus by installing Globus Connect Server. This runs only on Linux. Globus Connect Personal is the personal version of Globus Connect, and you can install this on your laptop, on your desktop, on a lab server, Anywhere where you have Linux, Mac, or Windows, you can install that, and it runs in the background, and it allows you then to access the data on that system yourself, nobody else. It does have a sharing capability. That's kind of an advanced feature, but really it's intended for single user use. It's intended for you to make your own system available via Globus so that you can use our beautiful interfaces in order to access the data on it. The third piece of software is the Globus Compute Agent. So if you have access to a compute system, whether it's a cluster at your university or in your research team, or a supercomputer at one of the national supercomputing centers, or a Department of Energy national laboratory, or even a system in another country that's been made available to you where they gave you an account, you can install the Globus Compute Agent, and then you can execute Python functions on that system. We'll show you how in one of the segments of this tutorial, without having to log in with SSH or anything like that in order to access that system. So it's a much easier way, much simpler way to use a compute system that you've been given access to simply by executing Python functions. And Steve is going to show you how that works in a little bit. Whoops, there we go. We work with a lot of different storage systems. So if your data is in the cloud, in any of the major cloud storage systems, or if your data is on a research computing system that maybe has a tape archive or some kind of mass storage system, you can still connect it to Globus. We have connectors that support a whole bunch of different systems. And so I don't want you to think, oh, well, my data is on some bizarre system. There's no way that Globus will be able to access it. The chances are you can. And so I just wanted to throw up this little slide that shows you that there are a lot of different storage systems that we support. And why have I lost control? There we go. Okay, let's take a look at Globus from the perspective of a researcher really quick. But before I do that, I want to just make a process check. I have not been able to watch Zoom very carefully myself. And so I'm hoping, Steve, are you going to be able to watch for questions and answers? I'm sorry, questions. I actually do see there's a fair amount in the chat.
I've already been monitoring, so all
Okay,
good. Yeah,
we're all good?
all
Okay.
good.
Okay, so keep watching, and Steve, feel free to interrupt me at any point if anybody has a question.
Will do.
I'm just kind of breezing through these slides, and so let me know. Okay. So key points about Globus from the perspective of a researcher or a research software engineer. We have one Globus service that's available to the world, but it has many different interfaces. So we have a command line interface that you can install as a Python package. We have our the main interfaces, which are the web. You can open your web browser to app.globus.org. Our web app is there. All of the Globus services have some representation in the Globus web app. We also have our Flows interface, which I'll be showing you how to use in this tutorial. We have our RESTful APIs. So if you're not using Python, maybe you're still developing code in, maybe you've got some research code written in, God forbid, Fortran or Ada or something like that. You can use our RESTful interfaces in order to interface with the Globus services that way. So there are a lot of different interfaces for accessing it, but it is one service. And things tend to work the same. Security features that are important for researchers. First of all, we are integrated with your campus research system. So whatever you use for single sign-on for your campus is probably how you would also sign in to Globus. So you do not have to create an account. Your collaborators do not have to create new accounts probably in order to use Globus. You already have an account that you can use to sign in with Globus. If you've ever used Gmail or Google Drive, Google Docs, anything like that, If you've ever used the ORCID system for keeping track of your publications or anything like that, you can use those accounts to sign into Globus. We also most likely already work with storage that you have available to you on campus. If your campus provides storage for researchers or compute for researchers, you can use the same account with Globus data transfer and the web app that you would use in order to access that storage on your system. And you probably already have Globus Connect or installed on the system. And increasingly, we're seeing administrators install the Globus Compute agent as well to allow people to access their compute systems via Globus. The data, Globus does not provide storage. So even though we're all about data management, it's bring your own storage, which means your storage stays, your data stays wherever you created it. And when you transfer it with Globus, it doesn't go through our servers or anything like that. It goes directly from your source system to your destination system. So it's important to understand that from a security point of view, you're not sharing your data with Globus, and you're not allowing Globus to execute compute on your systems or anything. We're only enabling you to do that. From the point of view of data integrity, whenever you do anything with Globus with your data, we always make sure that we do integrity checks. We use very sophisticated ones because at the research scale, a lot of the commercial data integrity checks actually fail because they were designed for smaller amounts of data, and they never anticipated that people would be using them with terabytes or petabytes of data. And so a lot of the weaker integrity checks will miss things that Globus will actually find. And so we are, excuse me, designed to do integrity checks on very large amounts of data all at once. We can also enforce encryption of Globus well, um, all Globus command and control, all of our API calls and things like that are always encrypted. So whenever you do anything with our login, whenever you do anything with making requests to Globus, that's always encrypted and private. Whenever you transfer data, you can also make sure that the data is encrypted during transmission if you choose. That's not the default unless you're working with protected data like controlled unclassified information or personal health information or something like that. Then it's always encrypted. But for normal transfers, encryption is not enabled because it is expensive and it slows the transfer down. But if it's important for you for data to be encrypted while it's transmitted, you can do that as well. Yeah, and so I'm going to very quickly mention that we do have high assurance features, which means that Yep. Okay. Which means that if you are working with health information, clinical information, or financial or educational information, student records, things like that, you can still use Globus with that if you have our high assurance features enabled. What they do is they basically soup up um, um, the security features of the system so that they comply with the federal regulations for managing those types of data. And your institution can then guarantee that you are not putting the institution at risk by um, making it possible for anyone to access data inappropriately. Let's see. Very quickly, from a developer's point of view, this is what we're going to be spending most of the tutorial on. I just want to give you a brief overview of what Globus looks like from a developer perspective. First of all, we have a whole bunch of things that are hosted in Amazon Web Services. We have all of our APIs are hosted in AWS, and they're available 24/7. They very rarely have any downtime. When they do, it's announced on our main announcement email lists. We have these services, an authentication and authorization service called Globus Auth, which provides login using your institutional identities that you already have, a data transfer service, a group management service called Groups, an indexed search service called Globus Search, which we're going to use this very briefly, but it's not the focus of this tutorial. And then the two that we're going to be talking about in this tutorial are flows and compute. Flows for automation and compute for remote function execution. So those are the APIs. We also have hosted in Amazon Web Services our web application, which uses all of those APIs in order to allow you to manage data and compute. We also provide, not in Amazon Web Services, but as Python packages that you can install, a command line interface, um, and our Python software development kit. I should have mentioned that when I was there. So the command line interface and the Python SDK are both installable as Python packages. With the Python SDK, you can build your own research application. That isn't something that Globus does for you, but you can do it using our Python SDK. You can build portals using something called the Globus portal framework, or we actually have a Globus Django portal framework and a Globus single page application framework that allows you to develop single page web apps. All of this uses the APIs that are available in Amazon. And then, as I mentioned before, you can install Globus Connect on your systems. This is not something that we do. This is something that you or your system administrators do. And it then allows the transfer service to reach out and access the data on your systems. Or you can install Globus Compute Agent, and that allows the Globus Compute service to reach out and execute things on your systems on your behalf. So you can then write your research applications or data portals to use the compute service or use the transfer service, and it then interacts with your stuff by virtue of the fact that you installed Globus Connect or the Globus Compute Agent. Any questions so far? Looks like somebody asked about.
There's one in chat. Which, if any, components are open source software?
Okay, so the stuff that we host in Amazon is not open source. So the API services are not, and the web app is not. But everything else that you see on here, Globus Connect, Globus Compute, Agent, the command line interface, and the Python SDK, they're all open source. And so the GitHubs exist for all of those. You will find it at github.com/Globus. And there are a lot of repositories there. Feel free to reach out to support@globus.org if you are looking for a particular repository, the source code for it, and can't find it. So you'll find the source code for the CLI, for the Python SDK, and for Globus Connect and for Globus Compute. These things down here, we don't share the source for them. It's not because we're grouches and don't want to. It's just because we don't actually expect anybody else to run them. And so, yeah, good question. Thank you. Okay, the Globus APIs. Quick rundown. I already talked briefly about this, but Globus Auth is an API that allows you to add essentially research logins to your application using research institution sign-ons that people already have. So if your application allows people to log in using Globus Auth, they can say, hey, I'm at Harvard. I want to use my Harvard ID to log into your application, and they can. Or, hey, I have this Gmail account, and I want to use that to log into your application, and you can do that. So we support Orchid, Google, GitHub logins, and I can't remember what the other kind of social logins are. But the most important thing is that we support about 2,000 different university and research lab logins for people who already have accounts at those places. Globus Groups is a authorization and membership service. So basically you can define your own group, give it a name, add people to it, give people administrative rights over the group. And then you can use those groups for permissions in all of the Globus services. So that includes transfer, search, flows, and compute. Can all have permissions based on Globus groups that you define in the group service. Globus Transfer is the API for data transfer and for sharing. We call that guest collections. And I want you to remember that the things here that have an asterisk on them, the star, are hybrid cloud. That means that we provide the transfer API and the transfer service that actually does the work, but you or your administrator are responsible for installing Globus Connect to actually make a system accessible via that API. Search is an index search and discovery service. It's based on Amazon's, whoops, sorry about that, Amazon's Elasticsearch. And it basically what we do is we provide Globus groups and Globus authentication and authorization permissions to Amazon's Elasticsearch. So, and we also host the index for you. So you can create new indices in EC2, and you can start putting things into them, and we do all of the hosting for you. You don't have to do any interactions with Amazon or pay for your index at all. Globus covers the bill for that. And so basically we host your index, and we make it possible for you to give permissions to it based on Globus IDs or groups. Flows is the automation service, and compute is the function as a service. And since that's the topic of the next two sessions that we're going to go, or next two segments of this tutorial, I'm not going to say a whole lot more about them. Some of the things that people have done with the Globus platform, this is not with our web applications, but by developing their own web applications using our Python SDK and the Globus command line interface. There are a lot of research institutions that have built web applications that offer, you can see here, NCAR, the National Center for Atmospheric Research's Research Data Archive. They provide a Globus transfer service or Globus transfer access to all of the data in the Research Data Archive. Same thing for the Sanger Imputation Service in the UK with the Wellcome Trust Sanger Institute. USGS is working with us on a new implementation of USGS's science-based data repository, which is the data repository used by USGS, US Geological Survey research teams. And it's all built on Globus Search and Globus Transfer and Flows and Compute. And so this is just to show you that there are a lot of teams around the world that have decided to build their application using Globus. Why did they make that decision? The last thing I'm going to say before turning it over to Steve. The reasons are because we do a lot of the plumbing work that needs to happen in a research application for you. When you build a house, you don't custom build your own plumbing system. You hire a plumber, and they come in and they do the plumbing while your house is being built. And that's because there's no reason for every person on the planet to be a plumber, right? Globus does a lot of the plumbing for building research applications. All of those APIs that I just mentioned are common problems that every research software engineer has to do in their application at some point or other. And Globus has already provided some of that for you. And so you can keep your web application small, and you can also make it possible for it to be run just about anywhere. The thing that the common mistake that research software engineers often make is that they put all of their data and compute behind their institution's firewall. In other words, they deploy it in their research lab, or they deploy it in their department at the university, and it's behind the university's firewall. And what that means is that if somebody needs to transfer data into or out of that application, and if the data is there on the same systems where the web application is, you have to go through the firewall, which slows things down dramatically. With Globus, you can put your data on the research institution's high performance storage systems, which are not behind the firewall. They're actually in a DMZ area of the network that has special protections on it and has very limited access. It only is available via Globus. Gosh, I'm sorry, I keep on hitting that button. And so basically you can have very high performance data transfer into and out of your application because the data isn't actually going into and out of the web server. It's going through Globus, and you're just reaching out with APIs to orchestrate the data transfers. Similarly for compute, your compute systems, you can have your application take advantage of your university's high performance computing systems, clusters, whatever, or if you have an allocation on a national system, you can have parts of your application execute on those using Globus Compute. Is there anything else I wanted to say? Yeah, if your application has any searching features in it, there's absolutely no reason why you need to learn how to use Amazon's Elasticsearch yourself. You can use Globus Search. You can do all the permissions based on the login identities that people are logging into your application with, and not have to worry about Amazon's keys and secrets and things like that. Use the same system for everything, same authentication authorization system for that. And I think that's it. So very quickly, we're going to show you these resources again, but our documentation is always at docs.globus.org. We have mailing lists, globus.org/mailing-lists. And the most important thing on here is support@globus.org. Our support team is amazing. You would never expect that a university-provided service could provide support as good as what our technical support team does. We love them and we rely on them heavily, and they do a great job. You can ask them you might think it's the most esoteric question about Globus imaginable, and they will hunt down and find the answer for you and get it to you quickly. So remember, support@globus.org. These people are there to support you, and they do it very well. Whoops, sorry. All right. So it is time for me to turn things over to Steve. We are now going to dive in to the first of the Globus APIs and services that we wanted to share with you today, Globus Compute. Steve, are you ready?
I am ready.
I will stop sharing.
There you go. Thank you. All right. I didn't see any other questions in chat.
I will keep an eye.
Yeah, okay. Sounds good. Let me go into here. Oh, hold on 1 second. I want to share this screen. And we'll go into. Okay, can we see that okay?
Yes.
Great. Okay, so yeah, as Lee said, I'm going to be talking about Globus Compute Platform. One thing that I found about the Compute Platform, and I hope you do too, is that it's actually fairly simple to get up and running. To get a compute endpoint that's running somewhere, whether it's an EC2 instance or even local, is a few simple commands. So I'm hoping as we go through this, you'll find that as well. We'll take a look at the representative picture of what research computing is today. This is according to Access CI. Access provides a lot of powerful computing resources, but only about 70% or so institutions use them and have 5 or fewer users. So on the high end of those is places like Cornell, MIT, large UC schools. On the lower end, Delaware State, Southern Arkansas. And you can see that the pie chart here, where there's only one user, is the greatest, is about 43%. And then really small pieces of the pie as you get more and more users. So why are there so few users of these resources at the vast majority of institutions? The fact of the matter is that real computing is notoriously difficult. Let me get this out of the way if I can. There we go. You have to deal with things like authentication, managing networks connections, managing jobs, interacting with those resources, and waiting in queues, what the environment is for configuration, and getting those results back again. So the researchers have to overcome all these obstacles every time they want to have a new resource. It's the same way that I think Lee spoke about this on transfers. We want to strive to not let data management get in the way of research. We also don't want computation management to get in the way of research. Moving forward, so how can we bridge this gap? A lot of researchers want to move closer to their environments. They primarily work in high-level languages, things like Python, and R and those types of scripting languages. Functions are a very natural unit of computation. There's a lot of script writing, a lot of functions as a service. The functions as a service model allows these researchers to work in those familiar languages, Python. And then we can then move on to using more familiar interfaces like Jupyter, which I'm going to show you in the hands-on. So how we as Globus asked how can we deliver this? So we're borrowing a page from the management playbook, a fire and forget computation. So you set up a compute resource on an endpoint. You set up a function to call that endpoint and essentially fire and forget. It goes to Globus's managed compute, and that sort of event structure sort of manages it there. It has a uniform access interface, which is, again, either through a command line or through the SDK. Lee mentioned the Python SDK. You can use that to get a client to your compute and run it from there. Federated access control. Lee talked about Globus Auth and the fact that we have around 2,000 IDPs. You can essentially log in with Globus Compute to whatever IDP you want. I will be logging in using Chicago, but you can log in using any resource that we provide. Fast network to make the compute resource seem local. So wherever your compute function is, it's going to run pretty fast. So we help bridge the gap for these researchers to be able to actually use compute resources by creating managed federated functions as a service, very reliable and scalable, and very secure in executing those functions on the remote endpoints. And these you can run these functions on anything from laptops all the way through up to supercomputers. We've seen everything from laptops to supercomputers running these endpoints. So what does the Globus Compute model look like? We have the compute service, so that is running, and it's highly available. It's cloud hosted, and like we said before, it's a fire and forget function execution. That compute service acts almost like an event queue where when you register your function, it's registered with a compute service, and it's listening for any invocations of that function. And when it sees it, it's going to run the function, and if it returns something, it's going to store the return for a period of time. I will get on some limitations later, but just so you have a little bit of a high level of what this compute service looks like, and we'll see in another slide or two a sort of diagram of what it looks like. Maybe it'll give you a little bit of clearer view of what it actually does. Then you have a compute endpoint. This is what you're going to create to connect to the compute service. It abstracts access to compute resources from edge device to supercomputer. And then working as a service to talk to the endpoint is our SDK. It's a Python interface, just like a lot of Globus resources. You can interact with the service, and a very familiar interaction with the Globus look and feel. And then that security layer of Globus Auth, I'm going to get into there are single user and there are multi-user endpoints. And I'm going to get a little bit into multi-user, but we're going to mostly focus on the single user since the multi-user is a little bit new. But I will touch on that. Okay, so here's some limitations. These are questions that are asked quite a bit, so I figured this was a good slide to put up. We do, since we provide this as a service, we have to rate some things. We have to limit some things so that the service doesn't get overloaded. One of those things is task rate limiting. It controls the rate at which you can submit new tasks to Globus Compute. What is that rate? It is 20 requests per 10 seconds. So every 10 seconds, you can send the compute resource, you can do 20 requests. If that submission rate's exceeded, you're going to get a max request exceeded exception from the SDK. And we would suggest if you need to avoid rate limiting, there is batching resources that you can use. There are data limits. So I touched on this. When a function returns something, it's going to return it to the compute resource, and it's going to store it for a period of time. So the data limit is about 10 meg on task submissions. Again, you'll get a Globus API error exception saying that the task payload is too large if you're trying to submit anything larger than 10 megabytes. The task time to live. Generally, there's different use cases for the task time to live. So how long does your data persist at that layer? Globus Compute considers a task to be abandoned when there hasn't been any activity on that task for more than 2 weeks. So your time to live there is fairly significant in 2 weeks. If you don't grab your data from compute resource, it will let go of that task. I will pause to see if there's any questions here so far. Sometimes I go a little fast and I want to slow down here and make sure that we're good with questions. I can't see chat, Lee, so if there's anything, just interrupt me.
Yeah, I was just answering in chat, but I'll since we have a break. The question was, is there something similar to compute, something similar in compute to high assurance for secure computing, or compute in high sensitivity scenarios? The quick answer is no. We haven't gotten to high assurance for compute yet. But the important point is Steve hasn't quite gotten there yet. But what you're going to see with Globus Compute is that it's mostly about it's about giving you another interface to use a system that you already have access to. There is no sharing in Globus Compute. And so it isn't possible for somebody who has an account on a system to share access with somebody who doesn't have an account on the system using Globus Compute. That's not a feature that's in there yet. And so most of the concerns about high assurance come in when you're sharing data with other people. In this case, it's basically an alternative to the command line. So you already have to have an account on the system. You already have to have a network connection to the system. And so it's not like we are opening things up any farther than they already were. It's just that we're giving you a different way to interact with the system. But still, the answer is no. There is. Go ahead, Steve. Sorry.
No, thanks, Lee. Appreciate that. Okay, so this is a typical user interaction diagram for Globus Compute, and there in the middle is that compute service that I was talking about. So we have a compute resource, another compute resource, and a user down here. So this user, as the user, requests a function be executed on endpoints A and B. This is going to go to the compute service, and it's going to look for a configured compute endpoint somewhere, wherever that exists. Second is going to Globus Compute manages the reliable and secure execution of these endpoints. So you're executing these endpoints on A and B. The compute service is going to pick that up, run those functions, and it's going to store any return data that comes from it. I jumped the gun a little bit there. Number 3 says Globus Compute returns results or stores them until requested. So again, all of this is running as a centralized service. And when you configure an endpoint, it gets registered to our service. When you call the function, the compute service realizes that it's being called, calls the function, and then if there's return, stores those results and stores them for a period of time for you to retrieve it. Okay, I think No, okay, no, we have a couple more slides here, and then we'll get into actually the using Globus Compute portion of this. I'll move a little quick through these because I think the main thing here is sort of demonstrating the actual use of this. Globus Compute transforms any computing resource into a function serving endpoint, a function as a service. Easily pip installable. A lot of our services are exactly that. They're Python pip installable. So you have Python and pip on your resource, you can install our SDKs and our services. It's an elastic resource provisioning from local cluster or cloud systems via something called Parcel, and parallel execution using local fork or via common schedulers. So there's a lot of questions about schedulers for compute. Slurm, Cobalt, and Kubernetes are all available. We sort of already talked about this. So again, I'll move a little quickly. Executing functions. Users invoke functions as tasks to the compute service. With a registered Python function, you pass input parameters and select endpoints to run the functions on. The service stores tasks in the cloud. Endpoints fetch waiting tasks when online, run tasks, and return results. And users retrieve those asynchronously. And you can see, any number of endpoints from a laptop to Argonne's Aurora supercomputer to and then folks invoking those functions on those systems. So here's again, we're going to be running through this. It's quite simple. It's a matter of having Python and pip available on your system. So this is for a single user endpoint. This is an endpoint that you register under a particular auth. So it's a pip install Globus Compute endpoint. And once you have that installed, it's a matter of just configuring that endpoint. So it's Globus Compute endpoint configure, the name of the endpoint. Once it's configured, it hasn't been started yet. So it's sitting there waiting to be started and spun up in the compute service. And then in order to do that, it's a very simple command: start US-RSE endpoint. I'm seeing a few questions. I can keep moving, Lee, unless you want to pause to answer.
Yeah, I'll really quickly answer a question. The question was, what are the default ports that Globus Compute endpoints use to communicate with the service? Can this be configured? So it's important. Can you really quickly go back to that diagram, Steve, where it showed one more? There you go. That's the one. Notice that the endpoint is connected only to the Globus Compute service in the cloud. And it's important to know that those are only outbound connections. That means the Globus Compute endpoint does not listen on any port. Okay, it never accepts an incoming connection. It only reaches out to our compute service. And the way it works is that the compute service has a RabbitMQ queue. And each endpoint has its own queue that it listens to see if there are any tasks that it needs to execute. And if there are, it executes them, and then it posts the result back into our compute service. So there are no incoming ports open on the compute system. It's only outbound connections. And the same thing is true for the user in the bottom left. The user does not ever listen for anything, any connection from our compute service. It only reaches out. So basically, from a security perspective, you don't have to worry about any open ports or firewall or anything like that. As long as things running on the system can reach out and open connections to the outside world, you're good. I hope that answers the question.
Cool. All right, thank you. Thanks, Lee. I'm going to move
Peter,
back.
if you want to follow up, I'll be happy to answer on chat.
So I think this is where I stopped here. This is essentially these are going to be the commands we're running as part of the interaction. If you're going to follow along a little in a couple of slides from now. So this is the single user endpoint. This is okay. So the multi-user endpoint's slightly different. When you we're going to pip install the Globus Compute again, but we add a flag. We're going to configure the endpoint, and we're going to register it as multi-user. This creates a few different configuration files. Not just this single one, but there's one important one that it creates, is an authentication, an authorization config. And within that authorization, that YAML file is where you're going to define who is allowed to run this function. It can be domain-based. So you can say, I want everybody from the uchicago.edu domain to be able to run this function, or globus.org, or whatever can run the function. It can be ID-based, so you can have single users run the function, even applications, things that act as applications and clients can run the function. So there's a lot of functionality in multi-user, but it's relatively new and not really the scope of this tutorial, but I just wanted to mention it because it is there and it is available for people to use.
I'm going to interrupt one time briefly because there's an important point here.
Sure.
Steve said anybody in the globus.org or anybody in your, whatever domain, they have to have an account on the system. There is no way for somebody who doesn't have an account on the system to execute something, even with Globus Compute multi-user. You still have to have an account on the system, and let's say I'm at University of Chicago, my lliming at uchicago.edu identity has to be mapped to whatever my local account is on the system in order for me to be able to use the multi-user endpoint.
Thanks, Lee. Configuration of endpoints, I touched on this, is done through YAML files. We have lots of different types of providers. And the one we're going to be doing today is just a simple local provider. But we have anything from container providers, Slurm providers. Within the documentation, you can find the different types of configurations. We have configurations for different types of supercomputers around. So I would encourage you to take a look at the documentation and see the various types of configurations and various types of endpoints that you can configure. Again, briefly, multi-user, this is that example identity mapping config. We're using identity mapping through Globus. This is a sort of regular expression language that we use to read YAML files and actually map identities. So here you can see we're mapping username, and we want to match that username with a globus.org domain and essentially output that username here. So if I had this identity mapping in a multi-user function, anybody from Globus should be able to run the function. Something we're going to see in the hands-on. How do we submit these tasks? They're done with the SDK and the executor. So this is the preferred approach to submitting tasks and collecting results. If you look at the SDK, it's a subclass of concurrent futures, and we're going to it's sort of asynchronous and submit returns a future. So, but the SDK automatically waits for those results, so you don't have to write your functions as async await. Yeah. Again, we're going to do this with a really simple function, much simpler than this. So this shows you, we're going to be doing this in Jupyter Hub as well. A very simple function here. We're pulling in the SDK, the Compute SDK, writing a function, and then getting that result by running, by submitting through the GCE, through that endpoint. You can see that we need the endpoint ID right here. Okay. So this is the portion where we would do some interaction. And I'm going to keep sharing my screen, but I'm going to minimize here. And I've lost. I think that's okay. Can everybody still see my screen?
Yes, we
Lee?
can.
Okay, thank you. Okay.
Keep that QR code up there a little bit longer, okay?
Yeah. Yeah. I was just going to say I'll give some time. I'm going to jump back to this, but if you want to follow along, this is where you're going to want to sign in and grab a server name. It should automatically give you that name as you fill these out.
If you go to the QR code, it will open up a Google Doc for you. And in the Google Doc will be a link to that sign up sheet that Steve just showed you. When you put in your name and your email address, you will get the host name and account information for an EC2 instance, and then you can SSH into it. Again, this is just so that you can install the Globus Compute agent, and then we'll be going to Jupyter and you'll be doing everything in Python.
I'll give some time if people want to sign up here. It looks like people are, so I'll give a minute for everybody or folks who want to follow along to get their server name, and I'll show you how to sign in.
I'm putting the URL in chat as well.
Okay. I think we might have maybe two people who are going to follow along. So basically what we're going to be doing, we're going to SSH. These are EC2 instances running in AWS that are provisioned for tutorial purposes. Looks like we have two people here who would like to follow along. So the first thing is getting into these. So if we SSH, and I'm going to use my admin2 at essentially, we're just going to do that. And there is a password. It's capital GLOBUS. So Globus -2024 with two hashtags on the end. So what I'll do is here, I'll write it out. I'm going to put it in another sheet here. And I'm just going to type it in here for people to copy and paste. Or I could type it in chat too, might be easier.
I'll put it in chat for you.
That would have been the more logical choice. Great. So now we have access to a Linux-based system. If we have Python installed on here, let me clear this so you can see the top of my screen. So if we do a Python version check here, we're running Python 3.10. We should have pip on here as well. Yep, version 22. So I'm essentially going to be following along. I'm just going to bring it into the screen here briefly. This is Globus Compute, read the docs. And under Globus Compute endpoints, there's a single user compute. And essentially, that's pretty much what I'm going to be doing. The first thing that you would want to do is you want to pip install. So we want to pip install Globus Compute endpoint. It might be installed on my system already, but I'm going to run it anyway. Might take a few seconds to install the package. So now if I do a pip list, we should see among our many modules here, we see some Globus Compute stuff. So that's what we installed. Let me clear this out again. So if I do a Globus Compute, Compute endpoint, and let's do a help to see some commands on here. So lots of different commands. Couple that we're going to run first. If we run a who am I, it should. Yes, so that's good. I haven't logged in yet. So it's going to say we don't have any user information, so we can't retrieve that. So we want to log in again. We're going to run compute endpoint login. So this is going to give you a URL that you're going to need to copy and paste. So we're going to copy and paste this. And copy. I'm going to go to my browser, copy and paste that. So this is going to ask us to consent to a few scopes here. This login wants to manage Globus Compute, view identity, and manage projects. Those are the scopes required to use Globus Compute here. So we're going to allow that. And it's going to give us a code. We want to copy that. And you'll notice here, I'm logged in under U-Chicago. So if you're logging in, you want to be consistent with your login. So my main account and login here is Chicago with my linked identities with Access CI, Globus, ID, Orchid, and so on and so forth. But my main account that I'm logged in through is University of Chicago. So let me copy this again, just in case I missed it. And we'll paste here. So now if I do a who am I should see that I'm logged in as University of Chicago, my user ID, and my email. Okay. Now, I'm going to run Globus Compute Endpoint. I'm going to run a configure. And I'm going to call this US-RSE'. Let's call it S-RSE' just to differentiate it between other US-RSE endpoints. So we configure that. Very simple. It gives us this is where our config file is going to reside. So if we do a cat on that, whoop, missed a letter there. And we look at this config file. Again, very simple. It's a local provider, and the type here is Globus Compute Engine. This is where you would config your function to, or your endpoint to have a Kubernetes provider or a Slurm provider, and that's all in the documentation that I showed you from before. So we'll keep this simple. We'll keep it a local provider. Notice that it hasn't started yet. If I do a Globus Compute endpoint, if I do a list, it's going to give me the endpoints that I configured on this particular system. There are a way to get all of your endpoints, and that's through, you can do that through the SDK, through a client. But this Globus Compute endpoint list is going to list the ones that you've configured on this particular machine. So I've only configured that one, and you'll notice that it hasn't started yet, but it is initialized. So I want to start this one here. We'll supply it the name. All right. So this is registered now with the compute service. It has a UUID, which we're going to need to copy here. If we do, again, a quick list, now the status was initialized. Now you can see that it's running, and it actually has an ID. If for some reason you missed it here, you could always run that list and get this ID again. So now we have the compute endpoint configured. We have it running. So now we need a way to talk to this and run this. If you suspend your disbelief for a minute, you can imagine this running on a supercomputer somewhere close to your data that is going to run the function and analyze some data somewhere. So let me pause for a second again, because I'm going to jump over to Jupyter at this point. Is there any questions or any confusion that people are running into? I don't see anything in chat, and I don't see any hands raised, so I think we might be okay. Okay. So for good measure, we'll copy this again. And then we're going to go back to Jupyter. So this is jupyter.demo.globus.org. When you sign in, you're going to want to sign in with the same credentials that you configured this endpoint to on the EC2 instance. So if I sign in here with Globus, by the way, signing in with Globus means that you can sign in with any identity that Globus provides. So this is signing in with my U Chicago. Okay.
It doesn't show that Steve is using University of Chicago because he was already logged in with Globus before he started.
Yeah, thanks, Lee. I was actually just about to say the same thing. Yeah. Takes a minute. These are running in a Kubernetes cluster, and we've scaled it up so that it could accommodate more users. Got a little nervous there for a second, but it looks like we're making progress.
This is just launching the Jupyter notebook.
Yeah.
Instance.
Okay. So before I do anything else here, just to give a little overview of what's in this notebook, we have a lot of really cool different tutorials and examples. One is compute, which I'm going to show after this. But feel free, as you log into this, to check out anything else you want to look at here. Lee's going to be using these flows in his section of the tutorial. I'm going to create, for compute, I'm going to create a new notebook. I'm going to save it as, you can save this as whatever you want, but I'm going to save it as compute US-RSE and say rename. Now, I'm going to take a very complicated function called hello. Again, suspend your disbelief. This is a function that is crunching data, and it's doing something with data and outputting a result that you can then grab onto once it's done. But here you see our endpoint ID, and I hope I still have it in my, yep. So I'm going to copy and paste that endpoint ID here. I'm going to bring in the SDK first. So as the first part of this notebook, I'm going to bring this in, and we'll create another spot below here. I apologize for the jumping screens. I try not to do it too much, but sometimes it's inevitable with these kinds of things. I'm going to basically just grab on really to the rest here. I'm going to add a print statement here just to show that it's actually doing something before we get to this function here. So let's define the function. You can also do this if you want to copy and paste. Globus Compute read the docs tutorial, which is here. And this will give you parts of this function. I've just modified the function a little bit to allow for an input, a simple hello world program. So let's copy that function, and we'll add one more frame below. And we're going to actually run this as well. So that would be this portion of the function. Okay. So this is the point where we hope this works. I'm going to restart. Don't really have to do this, but sometimes for peace of mind, it's okay to restart this kernel here. We'll save it. And then we're going to run this stuff. So we'll run the import first. If you're not unfamiliar with Jupyter, when a panel is done executing, you're going to get a step here. So the step one is done. Now we're going to register the function, the hello name. So I'll run that. And we see that's finished. And hopefully here, we might get a Python discrepancy because this, remember from before, we're running Python 3.10. From what I remember, the notebooks are running Python 3.11. So you might get a warning. You can ignore that. It's just a warning that Python versions aren't matching. So we're going to run this and, oh. So again, I'm going to do University of Chicago. We'll allow.
This is logging the notebook into Globus. So the
Yeah.
notebook wasn't previously logged in.
Oh, okay. Let's try to reset this and run it one more time. Okay. The pitfalls of running something interesting.
So it's the Python version issue you were talking about? Is
It
that
must be, yeah. So you can see here, Python 3.11. So this should be running. I apologize for this. I did not receive this error yesterday when running this, even in the EC2 instance. I can try one other thing.
try running against the tutorial notebook or tutorial endpoint? Sorry.
That's what I was just about to grab onto. Yeah. What I think the problem is what Lee said before. I don't have a local user of S-Tirosi within my EC2 instance here. So I think if I created a user,
No, that's not the issue. You're not
this,
using multi-user.
yeah, okay.
It's fine. That's not the problem. It's the Python version
I
problem.
think you're right.
Let's
So
see.
we'll grab onto the tutorial endpoint here, and this should work. This is a special endpoint, I will say, that pretty much anybody can use as long as you're part of the tutorial users group.
I mean, another solution would just be to upgrade the Python on your EC2 instance.
Yeah. So when this is done, we should see, there it is. Okay, so it looks like the Python versions are definitely the issue there. So the lesson there is Python 3.11 running on your compute server on your compute endpoint. If you're going to be running it in Jupyter Hub, that is, it needs to match versions. So we can run this against the tutorials endpoint, which will give us our results. Apologies that it didn't work with Python versions. So again, I'll pause here for questions. I was going to run through the compute introduction as well. That would be pretty quick. Lee, is there time to do that, or should we kind of move on?
Sorry, I thought I was muted. Well, it is 9:28, so we are bumping up against our break time.
That's what I figured. Okay.
And everybody is welcome to continue trying things. What I would encourage you to do is go to the Jupyter notebook that Steve has open right now, the compute introduction, and follow along in there. You can either, if it works, you can put your own tutorial, I'm sorry, your own endpoint ID into the notebook here, like Steve did. If you have a problem like Steve did, though, you can always change it back to this public tutorial endpoint, and it'll work. So you can, if we're just having an issue today with the fact that the notebook server hasn't been updated with the latest Python yet. But yeah, you go ahead and go through that during the break if you feel like it, or not. We will take a little bit of break ourselves and watch the chat for any questions.
Sounds
And
good.
we will restart again at the top of the hour.
Okay. I'm going to stop sharing. Thanks.
All right, I'm going to go ahead and get started. Let's see if I can, there we go. The topic for the next 45 minutes, we're gonna take a move away from Globus Compute for a moment. We'll come back shortly, and we're going to talk about Globus Flows, which is automation. So Steve kind of gave you the reason why we think Globus Compute is useful for research computing, getting us away from having to log into systems with SSH and submitting jobs with scheduler commands, and moving to being able to execute the Python functions remotely using Python. Using just Python after you set up your endpoint. Um, Oh, yeah, before I did that, I was going to make one comment about the fact that we had the glitch with Python versions. So what's basically happening is that the Python version that is on the EC2 instances that we set up for you is behind the version that is being used in the Jupyter notebooks. And so the Jupyter notebooks are sending functions that are serialized, and your compute endpoint doesn't know how to deserialize them because they're using different versions of the code. Um, so the workaround that we'll be using for the rest of this tutorial is that rather than using the compute endpoint that you set up on your instance, we'll just use the shared tutorial endpoint. You might be saying, wait a minute, Lee, you told me that I have to have an account on a system in order to be able to use the compute endpoint. That is true for every compute endpoint except our tutorial endpoint. We intentionally disabled the security features on our tutorial endpoint so that everybody in the world, anybody who can log in with Globus, can submit functions to our tutorial endpoint. And all of the Jupyter notebooks that we're using have the tutorial endpoint set as the default. And so we'll just continue using that. Um, I hope that you believe us now that setting up a compute endpoint is really easy. It's just a few commands that you give, pip install, and then the configure, and then the setup. There are examples of how to configure it to run on a system where you have to submit jobs with Slurm or whatever scheduler the system is using. But it's really easy to do. And so you'll be able to do that on your own. But all of our tutorial notebooks use the tutorial endpoint as a default, and we'll just proceed with that. Okay, let's move on to flows. So another problem that we've seen in research computing is that researchers very often have to do the same things over and over and over and over and over again. Most commonly this happens when you're doing things like data collection. You have some kind of research instrument that you're working with, an MRI scanner, cryo-EM microscope, a sequencer for genomic sequencing. And you run samples through it, and you have to gather up the data and collect it all and put it somewhere. Very often, the instruments that we use in research don't have a whole lot of data storage associated with them. And so one of the first things you have to do when you're using one of these systems is you have to figure out how you're going to transfer the data that's generated on them to some other system, maybe across campus, maybe in your research lab, but somewhere it's got to go somewhere. Also, you very often want to share the results of your scans or the data that you're collecting with a group of other people who you're working on a project with, or in some cases, maybe even the public. Although usually there's stuff you have to do, analyze the data, produce some results or whatever, and then you share those results with the public. But anyway, there's usually some kind of pipeline that you have to set up in the research process between creating data and then archiving it, analyzing it, making it searchable maybe so that people can search for their particular results or discover the scans that you did for them. Anyway, there's a whole bunch of things that have to happen. And what we've observed is that the solution that most research teams, there are two solutions that most research teams come down on. One of them is doing everything by hand because it's just too hard to automate. And when you do things by hand, number one, it's a time waster. It means that you have to have somebody who points and clicks and does everything manually over and over and over again, which really is a bad use of a human resource. It's just silly to have somebody who's supposed to be doing research instead doing a whole bunch of basically grunt work, managing all of the data for the team. Or they build some kind of custom scripting or some kind of automation. And what we've observed in that case is that there are so many ways to get it wrong. And there are also so many ways to do it without it being done securely that it's often not done very well. So even when you're automating and not wasting people's time, you may be making sacrifices on security and opening yourself up to the possibility of somebody messing with your data or it being available to people that it shouldn't be available to accidentally. Or it's just not the automation that's built just isn't reliable enough. You build it in some way, and there are just a million things that can go wrong whenever you're working with systems like this. And so it doesn't work very well. And so that was the motivation for us to develop Globus Flows. Globus Flows is a system that you can use to define a series of actions that need to take place. Actions using Globus services like our data transfer service, our sharing, our compute service, also our search service to make things searchable, um, even groups. So you can even automate group management if you need to. So basically anything that you can do with the Globus APIs and the Globus services, you can automate with Globus Flows. What you do basically is you, in a nutshell, you define what's called a flow. A flow is just a sequence of steps that need to take place with inputs and outputs. You string them together into a flow definition. I'll show you that in just a second. You store that flow definition in Globus, in the flows service. And you basically get an ID back. You give it a name. You call your flow whatever whatever it is. Maybe it's sequence data archiver or something like that. You get back a UUID, and then anytime you need that flow to run, you just call the Globus Flow service and say, okay, run flow UUID, whatever, and bam, it just goes and it executes each thing in order. And you can monitor that in the Globus web app. You can see the history of all the times your flow has been run or you have run the flow and what the results were of every step. And Globus will handle the execution of everything itself. So that you don't have to worry about reliability and you also don't have to worry about the security because everything will be done using the same Globus security authorization and access control that we use for everything else. So what does a flow look again? What does the system look like? We have a flows service that is running all the time in AWS. What it allows you to do is it allows you to define new flows, keep track of all the flows you've defined. You can even see a library of flows that other people have developed and shared with the public, and ones that the Globus team has made available as examples, example flows. And then you can also see all the times that a particular flow has been run, what the results were, the history of all of that, even right down to each individual action within the flow, all the inputs and outputs and everything. Each flow is a sequence of actions. Whoops, I keep on hitting that button. A sequence of actions. As you can see on the screen here, there can be authentication actions, transfer actions, compute actions. You can have an action that is that asks for user input. So the whole flow can stop at that point and wait until someone hits a button that says, yep, I like how things are going so far, proceed, or okay, let's stop right now. You can add things to a search index. You can share data along the way. Any of those things can be done as an action. And then this flow, once it's defined in Globus, you can run either via our Globus web app, via the command line interface, via an API call, and you can even make it so that it runs based on a trigger that you run yourself. So you can watch for new data on your system, and every time a new directory shows up with the special file in it that says all the data has been written, just trigger the execution of the flow, and whatever processing needs to happen will happen automatically. All right, so let's talk a little bit about the life cycle of a flow. The first thing that a flow starts as is it gets defined as a JSON document. This JSON document basically just has a sequence of states. Each state is one step in the flow. The state could be something like process files, transfer files. In this case, this is a very simple flow that only has two states. And it looks like, if you look down here at the bottom, it says start at transfer files. So the first thing it does, even though transfer files is second in the definition, that's where it starts. First it does this, and then somewhere in here it should say what the next one is. Next is process files. It goes here, and then it notice that process files has end true here. That means nothing happens after this. The flow is done. And so if you get to the end of process files, it's completed successfully. So basically, you just write the flow in JSON, and we have lots of examples for you, Jupyter notebooks and sample flows that you can see in the Globus service itself in order to, it looks kind of complicated, but we'll go through this and you'll see it's actually pretty easy. And then you deploy the flow to the Globus Flows surface. So you can deploy the flow in our web app. You can deploy it using the command line interface, our Python CLI, or you can deploy it by API call. So today we're going to define some flow, a flow in a Jupyter notebook, which means we'll be using the software development kit or Python to deploy the flow. It's basically just you take some JSON and you define an input schema and tell Globus Flows, hey, I've got a new flow for you. Here it is. Give it a name, and it gives you back a UUID. You can, once you've created a flow and stored it in Globus Flows, you can assign roles. So it starts out being owned by or administered by you. You're the only person who knows about this flow. You can make it visible to other people. You can make it runnable by other people. You can even make it administered by other people so that they can update the flow or change these roles. And you can also give these roles to groups. So not just individual people, but also groups. So you could create a group that is all of your lab administrators, for example, and you could make all the lab administrators maybe able to run the flow that you define that analyzes data out of your experimental setup, whatever it may be. You can, now that you've got the flow there and it's visible to people, you or anybody you've made it runnable by can now run the flow either by starting it in the Globus web app where it'll ask for any inputs that you've defined in your flow and let you, for example, specify what your source and destination are, or how many places in this, how many places do you need to replicate your data to, and put in all the places. Whatever your flow needs as input, you can put into the web app. Or you can run it again by API call by specifying the inputs as Python parameters, etc. Or in the CLI, you can run it there too. You can then see in the web app the run that's taking place, and both when it starts, when it's running, and when it's done. Check out its state. It'll tell you, when it started, who started it, what state it's currently in, and then you can see even the status of each step of the flow. And that state is kept in the system for, I think it's either 30 or 90 days. I can't remember which, but you've got plenty of time then to see, everything that happened with that flow. And the good thing about flows is that you can run that flow over and over and over and over and over again, many times, and it all executes reliably for you, and you don't have to worry about all the details of keeping things up and having system monitors and getting alarms or pager alerts or anything when the system goes down or anything like that. Globus will do that all for you, and our operations team makes sure the flow is, I'm sorry, the flow service is running 24/7. All right, let's zoom in a little bit on a flow definition. We'll have another example in our Jupyter notebook, but here's a really simple one. Here's a flow with just one step, transfer files. In the state, well, first of all, in the flow definition, you have to say things like start at. What is the first state that the flow starts with? In this case, we only have one choice because there's only one state, transfer files. Um, you get to name each state. So we'll call this one transfer files. You give it a comment that basically tells you later on when you're looking at it what this state does. And then it's a type of action. That means that it's something that's going to happen. And the action URL is the URL of, let me see if of an action provider. An action provider is just a web service that is running somewhere. In this case, this is a Globus hosted action provider. It is our transfer action provider that can do all the things that the transfer API can do. This is the URL for that web service. The web service has been defined with specific input parameters and output a definition of what the output of the thing looks like so that you can then put it into your flow. Then you have to specify all the inputs that are needed by that action provider. In this case, transfer needs a source endpoint ID and a destination endpoint ID and a source and destination path. And then there's one other option that the transfer action provider needs, which is this a recursive transfer or not? In other words, do we transfer all subfolders as well as the one that you're pointing at? Or are you only transferring that top level directory? That can be either true or false. Yeah, and these are all inputs that are provided as input to the flow. When you launch the flow in the Globus web app, it'll prompt you for the source, destination, and whether it's recursive or not. If you are running this through an API, you have to provide these as inputs to the run method of the Flows SDK. And then let's see, you have to say where, oh, well, we're skipping over that, huh? You have to say where all the results of the step go. In this case, it goes into transfer files in the state of the flow. So that if there are follow-on steps, they can look at the output of this step and use that in whatever they need to do. Await time is the maximum amount of time that flows will let this thing go. So in this case, it's 60 seconds. It must be a very small directory that you're transferring. I don't know. But you can change this to whatever you want. And you don't have to have a wait time. If you don't have one, it'll just go as long as it takes. But if you want it to stop the flow, if this state doesn't finish in time, you can do that. And then you say, what is the next state? Oh, I'm sorry, I was wrong. I didn't look far enough down. There is a second state. We just didn't put the details of it in here. Set permission is the next step in the flow. All right, so that's the definition. There are two pieces to every flow, a flow definition, which we just saw, and an input schema. The input schema is another JSON document that basically says what inputs does this flow require. There are two reasons for having input schema. One is so that if you want to launch the flow from our Globus web app, it knows what inputs to ask for and can do type checking for you. So if you say, I need a source collection, it can make sure that it gives you the user interface, it gives the person running the flow the interface for searching and browsing for Globus collections and then browsing the collection and picking the right folder or file or whatever is needed as the input. If it's if you say it's a string and it has to match this particular regular expression, then it'll do that type checking for you before it even launches the flow. The other reason is so that if you're using it as an API call, it can type check the inputs of the API call before it actually runs the thing and say, whoop, you didn't provide the right inputs or whatever, before it goes ahead and tries to launch the automation. So the first thing you'll see here is it lists the names of the required inputs. In this case, it needs there to be a source, destination, and a recursive option. And then for each of those things, it defines what is each one of those things. Source is an object. In this case, it's a Globus collection. And so it'll put up the collection picker in the interface when you launch the flow. Or if not, if you're running it from API, you need to provide an ID and a path, a collection ID and a path within that collection. In this case, it's a string, and it needs to match this particular regular expression. And it has a maximum length of 128 characters. So basically, you get to say, what do the inputs to this flow look like? Once you have those two things, yeah, right. Before we go on with that, we give you lots of examples of Globus Flows. So you're not creating this stuff totally from scratch. We have several, if you click on, Globus provided flow here in the flow library. So go to the Globus web app, click on flows, and then go to the flow library. Then if you click on Globus provided flow, you'll see that there are some examples there. And for every flow that's in there, you can examine what does the flow definition look like, what does the input schema look like, and you can use that as a starting point for developing your own. All right, so that's all I wanted to do by way of introduction. We're going to spend the next 20 minutes going through creating a flow, deploying it, and then running it in Jupyter. So let me escape out of this. Whoops. That's the next section. Hang on. Get out of there. There we go. I'm going to go to Jupyter. You can still see my screen, right? Steve, can you see my screen?
Yes, can see it
Okay,
fine.
great. Okay. So back in our Jupyter Hub, which hopefully you still have open from Steve's exercise, or if you don't, you can look in the chat again for the URL to get to jupyter.demo.globus.org. And once you're in there, under Globus Jupyter Notebooks, look for automation using Globus Flows. This is a notebook that basically in it, we will define a two-step flow. Those two steps are initiate a Globus transfer task. So we're going to move some data from one of our tutorial collections to another. And then we're going to share that folder with a group. Okay, we're going to share whatever we moved with the Globus tutorials group, tutorial users group. Very important here. In order for this flow to work, you need to be a member of the tutorial users group. So again, if you go to our tutorial resources Google Doc, one of the things at the top of it is click here to join the tutorial users group. Please do that. If you don't do that, number one, you won't be able to access the Globus the tutorial collections. And two, you won't be able to share the data that's on those collections after you move it with anybody else. And so it's important that you be a member of the tutorial users group in order to run this. All right, so let's step through this and I'll tell you what's going on, and feel free to follow along in Jupyter yourself. So the first thing we need to do is do all of our imports, including the Globus SDK and the scopes part of the SDK. In case we have to log in, we are specifying a client ID for this notebook. So this basically identifies this Jupyter notebook with Globus if you have to log in. You may be prompted to log in. And if you do, this make sure that it's secure. If you, ideally though, you won't have to do that. It also has some defaults here, a source collection, which is the Globus Tutorial Collection 1 collection, and a destination collection, which is the Globus Tutorial Collection on one of the systems at Argonne, at the Argonne Leadership Class Facility, system called Eagle, It's a very big 100, I think it's either 1 or 200 petabyte um, storage system, and we have a tutorial collection set up there as well. So we're going to move data from the tutorial collection 1 to the tutorials on ALCF Eagle. And then my collaborators is the group that we're going to share with. That's the tutorial users group that hopefully are all members of now. So let's go ahead and execute that. First thing is to make sure that we're logged in. You can't do anything with Globus unless you're logged in. So this next block of code, which looks really complicated, is actually going to do something very simple, which is just make sure that you're logged in and make sure that you've asked for permission to use the transfer service, and the collections that we're going to be transferring to and from. The reason it's really complicated is because ideally it will pull the tokens that you need, the access tokens, out of the Jupyter hub that you logged in with to get here. So in other words, the Jupyter system, you already logged into this, so it should know who we are, so it shouldn't need you to log in. Notice that it did not ask me to log in again. That's good. That means that it was able to pull the tokens out of Jupyter Hub. For a real application, you would probably only need a few of these lines of code here. That would be the, the code that basically would display a prompt, have you log in with Globus, and then come back here and paste in the thing. Okay. Let's move on. The first thing we're going to do is fetch our identity. So we've already logged in. We've already told Globus who we are. We're going to get our identity because we need it to use some to create a unique identifier later on based on our username. So notice that it knows that I'm lliming at uchicago.edu. And it's going to send notifications to this email address. This is the email address that's associated with my account. So when the flow is done running, it's going to send email there saying your flow is completed. But we're also going to use that username to make a unique identity later on, and that's why we're pulling it out in the notebook. Now we're going to define the flow. So this is very simple Python code. Here's the flow definition. You just say flow definition equals, and then this part right here is the definition of the flow, okay? So let's take a look at what the flow looks like. It's got two states, transfer files, set permissions. It starts at transfer files. Again, this uses the transfer action provider, and it has parameters source and destination paths. It we'll decide whether it's recursive or not based on the flow's input. And then the next step is set permissions. If it doesn't finish in 60 seconds, it'll fail. It'll basically say, oh, flow didn't complete in time. Let's see, set permissions. What does that look like? It uses, again, it's the same action provider, the transfer action provider, but instead of the transfer action, it uses the set permission action. So set permission needs an endpoint ID and a path. So that basically is the Globus collection and the path within the collection. We're going to create a rule that gives read-only access to the group. This will be an input to the flow, I guess. I don't know why it's an input to the flow. And the identifier, well, basically the group that we set at the top of this thing is what we're going to pass into it. And so we're basically going to provide read-only access to anybody who's in the tutorial users group. Notice here that, oh, I guess it doesn't matter, yeah. So we're using the inputs to the flow for setting the permissions. So it's not using anything from the previous state as an input. It's only using when you see $.input here, that basically means we're looking at the input parameters to the flow. And then here's the name of the parameter, and I guess it's got a multi-part name, destination ID and destination path. So anyway, that basically is what the flow definition looks like. Let's do that. We're just setting a variable here. And then the schema, again, let's get down there. You have to provide input. The input requires a source, destination. Is it recursive or not? And then is it a group or a user that we're giving permission to? And then, oh, that's the principal type. And principal identifier is which user or group are we giving permission to. These are all the inputs that are required. I'll let you look at that later to see, yeah, it's a string, it's a true or false. It's a UUID, it's got to be formatted as a UUID. All those details are in there. Okay, once we've set a flow definition and a flow schema, the next step is to actually create the flow or deploy it. We call this deploying in Globus. And so basically we are using Globus's flows service. And so we have to create, when we logged in, we created a flows client. This is basically the Python object that we use to access all of the SDK methods. And we're using create flow. And we're passing in a title. This is where we use the, I was wrong. We're not actually using our identity to create the random number. We're just randomizing a string of 4 random digits in it. Yeah, hexadecimal numbers. Anyway, this is what the flow title is going to be: tutorial -transfer -share, and then 4 random numbers. So we pass in the title, we pass in the flow definition, we pass in the flow schema, and then we get back this thing called flow, and it's an object, and it has in it an ID. That's the UUID that Globus will give it. And later on, we will print that down there. So let me just execute this, and you'll see what happens. Blammo. Oh, no. Oh, okay. I knew this was going to fail. This is failing because I am someone who is very unusual in the Globus ecosystem. I actually have, I'm associated with more than one Globus subscription group, which is really weird. That's because I'm a member of the staff. So you can see I have 3 subscriptions here. I need to tell it which of those 3 subscriptions I want to use. And so I have to add a feature. You do not have to do this. Subscription ID. I have to put in this little magical thing here to make it work. Oh dear. Oh, and I did it wrong. D equals. Thank you. Let's write real Python here. Okay. All right. When I do that and tell it, make it happy that it knows which subscription to use, it tells me, here's my flow ID. It's a UUID. Here's the title or the name. This is what will show up in the Globus web app. And yes, to view the flow in the web app, click on this link. So let's go ahead and do that. I'm just going to click the button, and it'll bring up the Globus web app, and it'll go to flows, and it'll show me tutorial transfer share. Here's the random numbers that it generated. Let's take a look. Here's the definition, and here's the schema. So now Globus knows about it. Notice that I'm the owner, and that's the only role, so nobody else can probably see this in the flows library. And notice that if I wanted to, I could actually start this right here in the Globus web app. Now it's going to ask me to, first of all, it wants permission to do this on my behalf. And I'm going to say, yes, you can launch this flow on my behalf. Sure, no problem. And notice here are the inputs that it requires. There were all the ones that we saw in the input schema: a source collection, destination collection, recursive is true or false. And then do we want to share with a user or a group, identity or group? We said a group. Here's the group. It's got a default in it. And then it wants a label. And notice that this is required. So basically I have to say my run if I wanted to run this. Now I haven't provided the source or destination yet. I'm not actually going to start it here. Let's go back to the Jupyter Notebook, and we'll do it using the Globus SDK. Okay. So we will start out. Here's how you run a flow in the SDK. First of all, we have the flow ID from above. It was up here, flow ID. And down here, oh, this is just to make sure that we have, so remember when I was up here and I said run the flow, it asked me to do something. It made me, give some permission. This is basically the code that handles that. And it's going to make me log in. So I will do that. tutorial allow. Here's my code, and I will paste it back into the notebook. Okay, now I have all the permissions that I need to run the flow. Oh my, I don't know why that didn't display. Okay, here's how you specify all so basically my flow input has to have all the things in it that are in the input schema, the source, destination, etc. We set all those variables up above, remember. Oh, here is where it uses my identity. This is the um, numeric identity that corresponds to lliming@uchicago.edu. It's going to move everything to a subdirectory. That's so we don't overwrite each other's files when we're all doing this tutorial together. Questions? Okay. So let's go ahead and do that. That's just basically setting up all the inputs. And now we can run the flow. And we will do that by, first of all, getting a Python client for the particular flow using its flow ID. So we pass in the flow ID, and it basically gives us back an object that we can then call where is it? Way down here somewhere. Specific. So now that we have a specific flow client, we can call run flow and pass in the input, pass in the label, and we can even specify tags that will show up in the web app if we want to keep track of this particular run of the flow. So basically it submitted the flow for a run, and it said this flow can be monitored in the web app. So let's go ahead and click on that just real quick, hopefully before it finishes. Let's see if I can catch it. Here's the run of this. It tells you this was the flow that you ran, but here's when it started and all of that. Here's the event log. Oh, it's already finished. The event log shows that it started and completed both of the actions, and it finished. If you want to, in the web app, you can actually look at what was passed in to set permissions as the input. And you can actually look at the output and see, this is the result of setting that permission. It did, details. Basically, access rule created successfully. So, that setting permissions happened and flow succeeded here. Basically means it's done. Let's go back to the notebook. It should, notice here that it pulled for status a little bit. That's Python code right here. That's what this while loop is. It was active, 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 and then it finally finished. And here is the output of the flow run that basically gives you the details of all of the states that were executed. So if you want to, you can go back and make sure that everything happened exactly the way you thought it should. Otherwise, you can just ignore this. So okay, I'm not going to bother with this stuff. This is just proving that it actually did what it said it would do. Let me go back really quickly, though, to, where is it? Transfer files. So here, okay, here's where it says where it transferred it to. Automation, okay, so it's this collection, which we can get to. Let me just really quickly do this. Go to the file manager. I can actually type in a number, or the UUI. That's the wrong thing to paste, though. Where did I get that from? There it is. Copy. You can type this in and it will find it. Globus tutorials on ALCF Eagle. This should be available to you if you're in the tutorial users group. And where did we send it to? We send it to this path. So it's got this automation tutorial, and then I'm just looking for B16B, I think. Automation tutorial. Oh, there's my directory that was created, and there are the files that I copied in. Okay, and if I look at, this is probably a bad idea, but I'm going to do it anyway. If I look at all the permissions, I will see that automation tutorial B16B, this folder, has been shared with tutorial users. So everything that I expected to have happen in the flow actually happened. Okay, so that's Globus Flows. So basically, The thing to know about Globus Flows is that the definitions and the input schema look really complicated, but they're actually easy to just follow the examples in creating. And once you get it right, you can monitor everything in the Globus web app if you need to. So you don't have to write Python code to monitor or even to kick things off. You can even run the flow. I'm viewing a run right now. I can click on the flow name. I can go back here and I can start it in the web app. Notice that it has defaults here. I can browse. Oh, yeah. Let's find that Go data directory there, specify that. I've already given it a default answer. I'll probably keep that. I can basically fill in the things here and give it a name, run from web app, and start the run. And it'll tell you the run started. This is the second run now. I can view the run details. I wouldn't be surprised at all if this fails. And the reason it'll fail is because it's going to try to set permissions on something that already has the permission. And so, if you were doing this for real, you would probably change the destination directory every time you ran the flow so that it was a different directory. I'm hoping that it's going to fail. Let's just watch. This is a good example of let's see, set permission started, but wait for it. I'm hoping that it's going to fail. Wait. You might notice that it's not the speediest system. Yep, flow failed, action failed. And if I look at the details, it'll say, yep, it exists. This folder is already shared with this identity. So you tried to set the permissions twice. Bad on me. So again, every time in reality, every time I ran this, I would specify a different destination directory, and then I could set the permission on it. But then let's go back one more time, go to flows, go to runs. You will see that here's the first run that I did from my notebook. This was the label that was set, and this one succeeded. This is the run that I did from the web app. You can always see that, yep, that's the flow that I was running, and this one failed. And then you can get the details of it in the web app. So it's really nice to have that history there. Are there any questions about flows? I know I've dropped a whole bunch of information on you. Part of the reason of making the Jupyter notebooks available 24/7 is so that if you want to, you can always go back and run through them again and review. But in the meantime, are there any questions? We've got a few minutes before we need to move on to putting this together with compute. I'm going to clean up my browser. Okay. Let's get my slides back for the next section. I'm just going to pause for a minute in case anybody is following along and has any questions, and also to catch my breath. The last section of the tutorial is on putting together flows and compute into one thing. So what we are going to do, I'll get there in a minute, sorry. No questions? Okay, very good. So in this last 45-minute session, we're going to run through a flow that has a compute step in it. So you might ask, well, how do I do a compute step or a compute function in a flow? And the answer is that we use the compute action provider. So this is another Globus hosted action provider. The URL for it is compute.actions.globus.org. And the input schema is an endpoint ID. Remember from Steve's section, you need to say which compute endpoint do I run the function on? And you need a function UUID. Which function am I going to run? And then you also pass in an arguments object, which is a list of arguments if the function takes um, a list of arguments. Or if the function it takes keyword arguments, you give it a Python dictionary of input arguments. So basically, this allows you to execute any function that can be defined in Globus Compute on any endpoint. So you specify the function and the endpoint, you pass in the arguments, and it will get run as one of the steps of your flow. The documentation for the action provider is in the URL on the screen, and it's, of course, linked off of the resource guide. Now, you may say to yourself, well, how do I get the UUID for the function? We didn't see that when Steve went through. Oh, darn it. Okay, we didn't we didn't see a UUID when Steve did compute, and that's because he kind of did things the simple way, the easy way, where you both define the function and execute it all in one step. For flows, we have to break those up. We have to define the function first and get a UUID for it from Globus. And then we can use that UUID in our flow. So you basically have to plan ahead a little bit. You have to define your function that you're going to put into your flow, deploy it in Globus Compute so that it knows what you mean whenever you call that function. And then you use the UUID that you get back in defining your flow. Don't worry, I'm going to show you an example. Oops, God. Okay, my trackpad just really wants to go forward. Okay, so here's the plan for what we're going to do. This is pretty much the whole rest of the session is going to be going through this example and helping you understand what's going on. We're going to create a flow, and that flow is going to have 3 steps in it. It's going to scan a collection in Globus. So we're gonna scan the contents of the collection, basically just one folder. We're going to generate a list of files in there that can then be that are in a good form for including in a search index. And then we're going to publish that list of files into a search index as a new entry so that it becomes searchable. So we're basically building up a search index of folder contents. Okay, so basically what this flow does is it publishes information into the index so that we can then search for things. We're going to use the compute function to do that second step, generating the file list. So we're going to take the output of the directory scan and morph it into a data structure that we can then put into the search index. Okay. And, oh, sorry. And then, yeah, we're going to use a shared search index. So everybody who does this tutorial exercise, you're all going to be using the same search index. So we're all going to be putting things into the same search index. And we will use the Jupyter Notebook to set up the compute function and the flow. We can run the flow. We're going to actually run the flow in the notebook. And there's a reason for that, but I won't get into that. But it could be run from the Globus web app if we wanted to. And then I'm going to give you a web application that you can use to search the search index. So what that means is that you'll be able to see new entries showing up as people run the tutorial exercise. So every time we run the flow, it'll generate a new entry in the search index and we'll get more results when we do our search. Okay, so we can actually see it happening. So again, let's go to jupyter.demo.globus.org, log in, and the notebook that you want is called Flow with Compute. Okay, so go to jupyter.demo.globus.org. The notebook is Flow with Compute. I will open that up now. I'm going to close this one. Open up Flow with Compute. Okay. You can do this notebook anytime, so you don't have to follow along with me right now if you don't want to, or if you're not in a place where you can do Jupyter right now. It'll always be here for you and you can run it. So basically, we'll start out with the instructions that say everything I just said. It is important that you be a member of the tutorial users group. Okay, the reason for that is because I have created a search index that can only be written to by members of the tutorial users group. So you have to be in the group in order to add entries to the index. Okay. Also, you need to be able to have permission to scan the folder that we're going to scan. And that's, again, the tutorial users group has permission to do that. So if you haven't already, click the link and join the group. Okay, now we're going to set things up. So basically here are the defaults. We're going to do a bunch of imports. Notice that we are importing both the Globus SDK. That's for everything except for compute. And then we're importing also the Globus Compute SDK, which is separate still from the Globus Compute because it's recent. It's a recent addition. Eventually it'll be part of the Globus SDK, but not yet. We're going to have this in case we have to log in. This is the search index ID that I've created for you. So this is my search index, but it's you have permission, if you're a member of the tutorial users group, to add entries to it. So you can add new things that are searchable. Here's the source collection that we're going to scan. It's, again, our friendly Globus tutorial collection 1. And here is the compute endpoint that we're going to use. This is the Globus compute tutorial endpoint. So all of us can execute functions on this endpoint. Okay. Let's see. Go ahead and execute that. Now we're going to authenticate and we're going to create a flow client and a compute client object so that we can use the APIs, the Flows API and the Compute API. It is going to make me log in, probably because it's been too long, but maybe because it needs permissions that I didn't give the first time I logged in. It needs to, let's see, it needs to manage Globus Compute. Okay, because I haven't done that yet today. Here's my code that I have to put in. Okay. Now I have everything I need to use the API. So, okay, let's first of all define our compute function. Okay, so we need a function. This is what the output of the directory scan is going to look like. It's going to come back and it's going to have, for every file, there will be one of these objects that basically says it's a file. Here's the permissions, here's the name of the file, here's when it was last modified, all this kind of junk. So it'll be one entry for each of those. And then here's information about the folder that you scanned. Here's the path. This is basically what the output of the list step is going to look like. We want to translate that into this. All it has is the path and a list of files. Okay, that is much easier to put into a search index and make searchable. We don't want all the rest of this gobbledygook around it. So basically our compute function right here, simplify file list, all it does is it takes it, oh, actually added something last minute last night. All we're going to do is basically it takes as input the folder contents object. It's a keyword argument in this case. That's what the star star means. And we're going to run through that data structure, pull out all of the file names, and also the path part. So remember up here, there's a path. We're going to pull that out, and we're going to create a new entry that only has these things in it. 3 things. Time published. So that's so that we can distinguish what we're doing today from everything that's already in the index. A path, and then the file list. That'll look like this. Okay, so whatever files are in there will show up as one of these list objects. Okay, that's our function. So we've just defined a function. Yay, woohoo. Now let's register the function with Globus Compute. So we have a compute object that we created above when we logged in, and we call the register function method, and we pass in the name of the function right here. Don't have to worry about arguments because that's going to be handled in the flow definition. Now we get back a UUID, and this UUID is what we're going to use in our flow definition so that it knows what function to call. It's going to basically, now Globus has made a copy in the Globus cloud of this function, and it's now callable to anybody who uses this UUID. Anybody can execute that. So when you do this, you're going to get back a different UUID and you can use your own function, or if you have amazing powers of memory, you can use my function and it should work, I think. But anyway, let's just go ahead. Here's the flow definition. What does the flow definition look like? First of all, here's the list step. This is going to use the transfer action provider. And in particular, it's ls action. So list the contents of the folder is going to use transfers ls. All it needs is an input collection and path. So we get the source collection and path, and we're going to put the results of that into the ls result area of the flow state. That's so that we can use it later on in the next step. The compute step looks like this. This is create entry. It's going to use the compute action provider. Okay. It's going to use the endpoint ID that I set at the beginning, so the tutorial endpoint, and it's going to use the function ID that I just got a second ago right up here. Okay. And it's going to pass in the results of the previous step. That's what this means. This $ls results details gets the results of the previous step, ls result here. Okay. That's going to be the input to the function. And then finally, oh, and the output's going to go into this create entry area in the state. And then the last step in the flow is add entry. It takes as input where is it? Content, yeah. Create entry details, it gets stuff down into the bottom somewhere of this state. That's basically the results of this function call. This is how you say, give me the results of the compute function. We're also going to stick in there the ID of the search index. So what search index are we adding this entry to? We created a subject. I didn't mention that up here somewhere. Somewhere we created a unique subject. Anyway, let's not worry about that right now. That basically is the name of the entry. And we're going to set it so that it's publicly visible. All right, that's that. The input to the flow, it has to have a source collection. And so this is a Globus collection. We just basically copy and paste this from any other flow that requires a source collection. And then what are we going to call the entry in the search index when we create it? So we've got to have a unique string. And that's what we're passing in here, the subject here. So let's set that. Let's deploy the flow. This is exactly like the flow that we did a second ago. It's just that it's a little bit different flow. And again, I'm going to have to put in my subscription ID. Darn it. I wish I had copied and pasted that. Subscription. This is just me. You don't have to do this. Let me get my, it's a pain. I should have used an account that wasn't really my real account. Then I wouldn't have to do this. Okay. Whoa. Oh, I typed it wrong. Subscription ID. There we go. Okay. Now it's going to deploy that flow. There it is. Okay, so I've created this flow. It's called tutorial list compute search, more random strings, just to make sure that it doesn't mess up any other flow you have. Here's the flow's ID. And I can view the flow in the web app. I'm going to do that. Let's take a look at the definition just to make sure. Yep. Add entry, list files, create entry. Yep, it's all there. And if I click on start and give it permission to start it for me, notice that the input looks different. So this one only needs a source collection and path, a unique string for the thing that we add to the search index, and a label. That's it. No destination collection, no is it recursive or not. That's because we're not transferring anything. So the Globus web app is a really good way to display a nice entry form for running a flow. But we're going to run it in the notebook. So let's create that unique string. Remember, every search entry needs to have a unique string. So let's go ahead and we're going to pull out our user identity, lliming@globus.org, add a random sequence of numbers and digits to that. That basically makes sure that it's unique. And that's what we're going to use as the input to the flow. Now let's make sure that we have a source collection and source path. Use that new entry subject that we just created a second ago. Authorize the flow. It'll probably make me log in again because it needs my permission. This only has to, run from notebook. Allow. We're getting to the good stuff here where we get to watch it execute. Hang on. Okay. We've authorized it. Now let's go ahead and call the run flow action. Okay, this flow, it should say this run can be monitored in the web app. Notice that it says active, run status active. It's gonna take a minute or two. Let's go to the web app and take a look at it. Event log. Okay, so you can see here, it started the flow. It scanned the directory. Let's take a look at the results. Nope, that's not the results. That's the results. Here's that data structure that I told you we would be getting out of. This is basically the results of the LS, okay? You can see, oh, whoa, it's already done. Okay, so list files happened. Create entry, okay? Let's take a look at the output of create entry. This was our compute function, remember? So what we should see here is in the output, let's see, in the output of our create entry, results. Here is the result of our function call. That better not be the result of the function call. Oh, yeah. Here. There's the result. It's just that data structure, time published, path, and the file list. So it basically took this big gobbledygook up here and crunched it down into that. Okay. And then it added the entry to the index, and it's done. So now let's go back to our notebook. And underneath here, I added the way that you can view this in the search index. So we have to create the URL. But if I click on this URL, it'll take me to a web application that just does a search on my index. And you can see result, 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 result. This is not a very nice web application. But this last one here should be published Friday, October 11th. That was me. This is GMT, so it's actually 6 hours ahead of me in Albuquerque. I don't know where you are in the world, but it's 6 hours later, I believe. Yeah, that's right. Here's the path that I did, and here's the file list. And so it actually did get added to the index. So everything, whoa, sorry, I didn't mean to do that. All these other results were from different days. Actually, there was a time when I wasn't adding the time published, and that's what that one is. So let's look at one from yesterday, I hope. Yeah, this was one that I published last night while I was working on this flow. So all these results are here. And if you go through the notebook, it will add more results to this right here. Now, you'll probably be scanning the same directory that I did, but if you go back to the flow library, you will now have, sorry, you will now have in your flow library this flow tutorial list compute search, and you can start it, and you can, if you want to, pick a totally different collection. So let me go ahead and do that. Sequencer, data, liming, see if it finds, this is a collection of mine, random collection. I'm just going to browse it, find this particular sequence, and I'm going to have to give it a unique, so remember how we constructed this in the notebook. We just did a random string, right? So that's what I'm going to do here. I'm just going to make a random string, and I'm going to run from web app. start it. Let's watch the details. So basically, I'm just running the same flow, but I'm giving it a different input directory to scan. Actually, since I did that, let me go into Globus and show you what's in that directory. Sequencer data lining. Don't worry, this isn't real gene sequences. Here's what the contents of the directory look like. A lot more files, right? They're all image files in an Excel spreadsheet. So anyway, let's take a look. Where are we? Here we are. Flow succeeded. Great. Let's go back to the let's go back to the web app that I've already closed and see. Here's the last result that's found. Yeah. There are all the files that should be there. Here's the path that it was, and here's the new time that it was published. So this is basically a way to, with a flow, add things to our catalog of folders and file lists and make it searchable. If I go back to the search interface, I should be able to type in something like, I don't know if this is going to work. It'd be really cool if it did. No. Let me see. Let me make sure that I got the right thing here. Let's see if I can search for an individual file name. I didn't actually test this, so I don't know if this is going to work or not. It might not. It's not smart enough to do that. Oh well, sorry. Okay, anyway, you can at least see that the results are in the index and that when you do a search, it pulls up the entry that is added. Any questions? In real life, we would probably have a flow that did something a little bit more impressive than just listing the files in a directory and adding them into a search index. We would probably do something like process those files, maybe get out some scientific, data from them, and the search index would have more than just a file list. It would have, name of the researcher who submitted the sample that was scanned, and maybe some calibration data. Basically, it would have other stuff in it. But we could still automate the whole process of getting it from the instrument to, we could probably combine this flow, right, with the one previously that transferred the data and then shared it. We could also analyze it with compute and add something to the search index. So it would just maybe be 5 steps instead of 3 or 2. And it would do all of that in one step. I'm going to stop sharing. Any questions? We have lots of time for questions if you have any.
Lee, there's a question in chat. Given you have to serialize all your dependencies alongside your own code when registering a function, is there a practical upper bound on how big a function can be?
There is. Let's see. Do we want to look that up right now? Do you know the answer off the top of your head, Steve, by any chance?
I do not. I remember coming across that, but I don't know the actual answer off the top of my head.
Okay. I'm doing a Google search for Globus Compute limits. There it is. Let me share the screen again because I've got the answer.
Oh, so we're talking about, okay. Yeah, the limits were before. I actually have that linked somewhere. But if you have it there.
I think I have it on the screen right now.
Yeah,
The current
all good.
data limit is set to 10 megabytes on task submission and 10 megabytes on result size. So I will be honest with you guys. I haven't used Globus Compute a ton before I was giving this tutorial. And when I put together this flow, I was like, I probably shouldn't point it at a folder that has too many things in it because I don't know that I can get that much data in, well, 10 megabytes would actually be a very large directory listing. So I don't think I would have had any problem with that. I was probably worried about nothing. So the answer is 10 megabytes on both all of the parameters you pass in and all of the data that you pass out. If you want to go bigger than 10 megabytes, the way that you would do that is probably in your function, whatever it is, write the data out somewhere that is accessible via Globus. So, set up a Globus Connect somewhere and make sure that it has access to the output from your function, wherever it's running, wherever your compute endpoint is. Write the data out, and then you could, in later stages of the flow, transfer that output data. So if, there are a lot of people, we didn't really talk about who's using Globus Compute and for what, but the reality is that it's been very popular in the machine learning community because machine learning, when you run a model on input data, it requires a fair amount. If it's a sophisticated enough model, requires a fair amount of computing oomph. And so people have their model deployed on, say, a cluster, um, and they use compute to execute to basically um, execute the model against input data and get output. Um, Now, very often, the input data may be big, but the output doesn't necessarily have to be all that big. It's, was this a good match? Was this not a good match? Is this a good candidate for this particular, for a, is this a good vaccine candidate for this particular virus or not? And it's, a very simple answer. But if the answer is complicated and it's lots and lots of data, or something like that. Or maybe if you're running a simulation in your compute function and you need to get the output of the simulation state as the function result, again, you probably are going to exceed this 10 megabyte limit. And so you want to write the data out somewhere and then use Globus to get to access the data in later stages of the flow. Did that answer that question? I hope. Okay. Any other questions? Thanks, Mike.
So Lee, one thing I want to say, I was furiously installing Python 3.11 on the EC2 instance. um, the function ran as expected. So the Python mismatch was the issue there. So make sure that when you're running
Frustrating.
functions and you're creating endpoints, that those Python versions are at least,
Yeah.
in the same realm. So Python 3.11, Python 3.10.
And we've got some homework to do, I think, in order to work on our tutorial setup so that in the future we make sure that our Python versions are synchronized between Jupyter Hub and REC2 instances. So I apologize for that.
Yeah.
Fortunately, we have a tutorial endpoint that allows us to submit to it. Um, so we had a good workaround for that. But in practice, you do want to make sure your Python versions are synced. It's a I realize that's frustrating. Um, it is a frustrating limitation, but I have not seen any better, um, solution to that in practice out there in the wild. It seems like whenever you are doing remote Python function invocation, serializing and deserializing, you need to make sure your Python versions are synchronized. And it's just one of those many banes of the research world that we all have to deal with. One thing that I will mention about, actually, yeah, I should have said this with regard to that Python synchronization issue. Um, there is a container as a container backend to Globus, the Globus Compute endpoint. So what you can do is you can have all of your functions execute in a container, and you can make sure that that container has the right version of Python in it. So even if you are running on somebody else's system, if they provide a containerization backend, you can take advantage of that to pin the right version of Python. And then, sync it with whatever your client is. Any other questions? Steve and I are going to hang around for another 15 minutes. If you are trying things out, playing around, experimenting. If you want to drop off, that's fine. But we will be here for the next 15 minutes to do Q&A. Also, I want to remind you, and why do I not have my slides handy? Hang on. Sorry about that. Oh, am I still sharing?
Yes.
Good. Okay. Yeah, so I'm going to leave this slide up here too. So here's the link to the resources. Use the QR code if you want to get to the tutorial resources. The tutorial resources will be available, the document, the Google Doc will be available forever. I'm not planning on taking it down anytime. The EC2 instances, if you want to play around with setting up a compute endpoint, I would encourage you to do it on your own system if you have Python available. But if you want to, you can use our EC2 instances until I think next Wednesday is when we're probably going to take them down, because we're going to use the same set for the workshop at US-RSE on Tuesday. And then I also want to remind everybody about the survey links. The tutorial committee and workshop committee at US-RSE would really appreciate it if you filled out the tutorial survey and the DEI survey. So I'll leave this up here for a little bit. Happy to answer questions.